Chris, obviously the big buzzword when it comes to innovations and literally innovations in rotorcraft technology right now has been all the excitement built up over X2. But X2 for Sikorsky is the tip of the iceberg. So let's talk X2 first, and where do you go from there?
X2 is one of many technologies we're maturing, as you mentioned. Adding to X2 is technologies in the area of making our helicopters aware and adaptive and making them optionally piloted.
What's the state of the X2 program at the moment, and if you can give us kind of a timeline for what you expect to do with that airframe and that project for the moment?
We're past 100 knots in the development program. This year we hope to complete our 250 knot full envelope expansion, and we're at the very exciting phase. The prototype is in West Palm Beach, Florida. The build for the high-speed flight is completely done now. It's going through testing of the final software and hardware changes we made for the high-speed flight, and we'll resume flight shortly.
250 knots is an incredible benchmark for anything with a rotor, much less a coaxial rotor and a pusher configuration. The modeling on this just must be absolutely extravagant. But what kind of benchmarks are you looking at from a technological standpoint that need to be either defeated or mollified in order to build a vehicle that's going to be able to breed a whole new generation of rotorcraft?
Right. Well, our goals in the X2 program are to not only demonstrate the 250 knots, but demonstrate efficiency. The drag reduction technology in the X2 is applicable to a wide range of rotorcraft. We also need to demonstrate that we have a smooth ride at 250 knots. The original XH-59A demonstrator showed the physics at 250 knots, but didn't have an acceptable ride quality at 250 knots. The fly-by-wire flight controls, active vibration control, composite technology in the main rotor blades, new aerodynamics, we think stitched together in a nice way to achieve these goals.
Cirrus Design's Vision SJ50 single-engine personal jet offers exceptional fuel efficiency, flexible seating for up to 7, advanced avionics, and all the Cirrus safety features you expect, including the Cirrus airframe parachute system. With its V-tail design, the Cirrus Vision is technologically advanced, yet engineered to be simple to fly, to allow owner pilots more lifestyle pursuits than any other personal aircraft. Learn more about the Vision SJ50 at cirrusdesign.com.
We've obviously seen a number of artist conceptions of where this technology might go from a standpoint of what an S-76E may look like in the future or something to that extent, or for that matter to military configurations. Are there any limits to that technology? Is this something that literally can go out and beat the V-22 at its own game?
Interesting. One of my favorite applications for it is to actually be a companion for the V-22. The current escort helicopter options, the attack helicopter, whether they're Cobra or Apache, struggle to keep up with a tilt rotor. An X2 Cobra Apache replacement would actually have V-22 peer speed to be able to escort the aircraft, break off and mix it up on the ground with a very agile, high-performance helicopter. The other one we're excited about is a light tactical helicopter for special ops. We've been shopping around a mock-up this year, which we call a 3D whiteboard, to get their feedback on what are their emerging requirements. But that basic vehicle moves 6 warfighters, very high speed, low acoustics, high agility, and the ability to hover in most of Afghanistan, to be able to assault the tops of the mountains instead of halfway up. That's what Special Ops is really looking for. And we hope to have it also be an option for the Armed Aerial Scout. The Defense Department has an interesting decision in front of them. They've been challenging the rotorcraft industry. You've got to accelerate the rate of innovation and do new things. Will, in the Armed Aerial Scout decision-making process, they choose to kind of stay the course with a commercial off-the-shelf derivative that can meet some of the needs, or introduce some game-changing technology with something like an X2 Armed Aerial Scout light tactical helicopter. That's going to be really fun to watch.
The Spec Ops people must love you.
They're excited. And they're excited, 1, because we're maturing the technology, 2, because they are integrally involved in the design process of the vehicle.
If you own a Cirrus today, or if you are considering the purchase of a new or used aircraft, consider this. Avidyne, in conjunction with the country's leading Cirrus sales and maintenance facilities, has launched the G3R9 program that combines the purchase of a late-model, low-time Cirrus aircraft and the addition of the Avidyne Integra Release 9 avionics suite. for much less than you may have thought, and certainly much less than purchasing a brand new aircraft. G3R9, combining the best airframe, best engine, and best avionics for the best value.
During the briefing the other day, we were looking at some of the diagrams and reports on active rotor technology. This is something that I haven't had a chance to study up on too much. I know you were working on it. Let's talk about that technology because, boy, talk about something with tremendous potential, especially both from the remotely or optionally piloted vehicle side or for other standpoints. Talk about something that can truly civilize the worst of commercial operations.
Mm-hmm. Last year, we are excited about active rotor technology. Last year we had 2 demonstrations in full scale, 40 by 80 wind tunnel test on a Black Hawk rotor with active pitch links that can change their length several times per revolution, dramatically decreasing noise and vibration, increasing performance. That was a great collaboration with ZFL in Germany and NASA. And as part of an AATD program, we've demonstrated an active flap on a full-scale blade. And the exciting thing there is it's not only the noise and vibration capability, but the technology we're pursuing could enable a path to a future swash plateless rotor, where each blade is literally individually controlled. There are several other active rotor technologies out there that are very limited authority. We're maturing a very high authority system.